Today's work is going to be on all sorts of fractions problems. Now, in the past, so far this year, we've actually done a decent amount with fractions already. We've looked at multiplying fractions, dividing fractions, and reducing fractions, all. One thing we haven't touched on yet, though, is adding and subtracting fractions. Because for some people, it ends up being a really tricky concept. But we're going to start off with stuff that really isn't all that tricky. And that's where these problems come in today. So go ahead and write down that first problem. And as you're doing so, just kind of a reminder or a refresher, kind of a concept behind this. For many of you, maybe most of you, maybe even all of you, these first problems or two that we do are going to seem so easy. You're going to be sitting there saying, why are we bothering to go through this? I already know how to do that type. And you're going to be thinking I'm wasting your time, but I'm not wasting your time here. We are going to be getting into harder ones, not today, but we are going to be getting into harder ones. But if you wait until then to engage your mind with this, you're going to miss the foundations that we're talking about today. Some of those little subtle pieces which you are going to say, oh yeah, I know that. But by the time you have to go and use it in a different way, you don't know it. And so it's a chance to kind of reinforce some of these ideas that let us work with things we see along the way. All right, so that first problem that we're doing there, 3/8 plus 1/8. Many of you are looking at that and you're like, oh yeah, I got the answer just like that. But I want to bring back why we can do what we do here. And I'm going to go back to the really old visualization. If I visualize trying to do 3/8 plus 1/8, I'm envisioning a whole. That's represented by this big old rectangle here. That's 1. And so I've cut it up into 8 pieces. So each of these pieces then represents 1/8 of the whole. So when we're talking adding and so on, when we're talking about adding 3/8 to 1/8, it's basically a way of saying that I'm taking 3 of those pieces, each of which is 1/8 big, and I'm adding to it another piece that is also 1/8 big. Now that I can do pretty easily, right? How many total pieces then have I shaded? I've shaded 4 pieces. So we get 4 out of 8, 4/8. That conceptual background, you're going to find that's going to be really important because later on, they won't both be the same denominator. We're going to be talking about how when they're not the same denominator that we're going to need to make them the same denominator. Not today, but later. And this is why. Because in order for us to be able to add them together, we have to be talking about the same things. You know, it's like combining like terms. In order for us to actually add them together like this, they have to be the same size. They have to be the same thing. All right. Now, I got 4/8 as my answer here, but I don't want to leave it like that. I want to reduce it. And again, the visualization can help with this here, because if I just take a look up at that bar right now, how much of that bar is shaded? Well, we'd tend to just describe it as half of it is shaded. It's just that we used to have it broken up into 8 pieces, and here I can see that I can get to the same place by breaking it up into just 2 pieces. This is what's really happening when you're doing the fraction addition and when you're doing the fraction reducing as well. It's just a matter of reducing is just a matter of taking it and saying, okay, well, what if I didn't want it in those tiny little pieces? What are some bigger pieces I could cut this into? So when it comes to the math side here, just the operations that I'm doing, notice then what I'm actually doing here. I'm adding the tops of my 2 fractions, and I'm keeping the bottom the same. That might be worth noting to yourself if you have trouble remembering that. And that works for adding our fractions, and it's going to work for subtracting our fractions. One big thing to note about though is my verbiage here. Notice I'm saying keep the bottom the same. If it's not the same, you can't keep it the same, so we're not going to be able to do it. And so you have to be able to keep the bottom the same when you do it. All right, and of course we reduce that. Technically what we're doing in order to reduce that is we're saying what can I divide both top and bottom by? And in this case I divide top and bottom by 4 to get that 1/2. Okay, no problem, hopefully. Second one, we now go ahead and apply the same idea here. So I'm just going to go ahead and subtract the tops. So 3 minus 1 gives me 2. And then I keep the bottom the same. And so that ends up giving me 2/8. Okay, so I got 2/8. Does that reduce?
Yes.
Yes, it does. What can I divide out of both the top and the bottom? 2. And so we get 1/4. Okay, now into multiplication. I want to multiply 3/8 and 1/8. So when I do that multiplication, What's that going to give me? Well, I multiply straight across the top, which gives me 3. And then, this is the part where all of a sudden it trips people up. Because all of a sudden people want to say 3/8. But it's not 3/8. Because remember, to multiply fractions, we multiply straight across the top and straight across the bottom. So even though they're the same, I still multiply them. So it actually gives me 3/64. Hence why I'm mixing in a little bit of the multiplication and division that we already know. Because when you see that we aren't learning something that's changing what we did, we're just seeing how it applies when we add or subtract. Multiplication still happens the same way, and division is still going to happen the same way as well. So, dividing. How do we divide by a fraction? Flip. And which one do we always flip? The first one or the second one? The second one, yes. And when we flip it, at the same time, on the same line, some people try to show this on 2 lines. It's not 2 lines, 1 line. When you flip it, that's when you change your division symbol into a multiplication symbol. Do it all on 1 line. Now that we've done that, now we can go ahead and do the multiplication. So multiply straight across the top, straight across the bottom. So 3 times 8 on the top, 24. 8 times 1, yeah, that's easy, that's 8. It's 24 over 8. Now let's reduce it. 24 over 8. Well, what can I divide both top and bottom by? 8. Now, some of you might not have been thinking it. Some of you might have been thinking 2 or 4. That'd be fine, but if you started by dividing up by 2 or 4, you're going to find it can go even further. 8 is actually the biggest one, and if you can find that biggest one, it makes your life a whole lot easier. So, we divide top and bottom by 8, which gives me 3 over 1. But I don't really like to leave it like that, because anything over 1 is just itself. So the final answer here is just 3. Whole number 3. So notice I can have 1 on top in my final answer, and that's as simple as it goes. But 1 on bottom, that's a whole number, so go ahead and leave it as the whole number. So now we're going to go ahead and take a look at this set. You work through each of these problems on your own, and now we take a look and see what you should have gotten out of each of those. So on this one, we go ahead and add them. Remember, add across the top, keep the bottom the same, so that's why we get the 9/6. And then we reduce it by dividing top and bottom by 3, so that's why we get 3 halves. Now this problem usually then creates a question. Do I have to then turn it into a mixed number because it's top heavy? The answer right now at least is no. We haven't talked mixed numbers, and we are going to, but we aren't worrying about putting that in right now. We don't need one more layer of things to worry about. We're just going to nail down one thing, get really good at it, and then we'll go on and add another layer after we're really good at this. So you can go ahead and leave it at 3 halves. If you want to go mixed number, you can go ahead and take that extra step. If you chose to do that here, you'd be looking at 1.5. All right, then we go on to the second one. When we subtract in this one on the top, we get a -1 on the top. And we keep the bottom the same, so it's still over 6. Now, it's time for me to be like math teacher picky here. I want to show you something that's probably going to be helpful for you going forward. And if not helpful for you, it'll at least be helpful for your math teacher. Because as I take a look at this, this is not a usual way that we see a number given. We don't normally write a negative within the fraction like that. Not unless we're doing a bunch of operations on it or something. So this negative being in the top of the fraction, it just looks awkward to my eyes. And so what we're going to do is we're going to change that. So the negative is no longer in the top. So how do we change it? Well, a fraction, remember, just means division. What's a negative divided by a positive? A negative divided by positive is a negative. And so that means that this -1 over 6 equals a negative number. So I'm going to write it like that. I'm going to write it as -1/6. It's a small little detail change, but it's a good one to know to make. And it also has other implications. Because like, what if it was a negative on top and on bottom? Yeah, that means our answer is actually a positive if that happens. Because the negative divided by negative is positive. So it helps us to understand why some of these little things happen along the way. All right. So that's the addition and subtraction, the new stuff. Now let's just make sure that that hasn't messed up the multiplying and dividing. With multiplying, multiply straight across the top, straight across the bottom still. And yes, that does reduce. I can go ahead and divide top and bottom of that one. by 4. So we get a final answer there of 5/9. Make sure you're reducing, make sure you're simplifying. Usually at this point somebody wants to raise their hand. I don't know if anybody's going to, but usually somebody wants to at least and say, but it doesn't say to reduce. Nope. And it's not going to half the time. But by this point, we are advanced enough in math that we should always know to reduce. So always reduce your answers as we go and get these, whether it says to or not. All right, and then the last one is division. So I'm actually going to route the flip the second and multiply. Remember, do that all in one line. And then go ahead and do the multiplication. I got 24 over 30. Does that reduce? Yep. By 6. I can divide top and bottom by 6 there, so that gives us a final answer then of 4/5.